All right, MAP4C day 54, our second day, excuse me, on rearranging formulas. And the 3-minute review has got, this is another physics formula, and it's famous in the physics world. This is the force of gravity that occurs between any two masses that are r units apart. Um, there's a little video there that, if you like, would make sense to me to watch this little video, um, giving you some background on this formula and what it means. Usually it's used to find out the gravity between two planets or between a sun and a planet, that sort of thing, how much pull they have, but we're going to use it to talk about Homer and donuts, which is awesome. Um, G is the gravitational constant, and this doesn't look very good on my screen here. I don't know if there was a typo on yours too, but this means this G is the gravitational constant, and it's 6.7 times 10 to the exponent negative 11. This is in scientific notation. And if you haven't taken much science since grade 10, you might have forgotten about this, but this is a way to write really, really big and really, really small numbers. And your calculator, when you get a really, really big or really, really small number, it'll give you something weird, and we'll see it when we get to the calculator. Okay, um, the negative 11 means I should go left to make it smaller 11 places. So this is 0.000000000 11 spaces, including the 6, and then 0.0000067, right, where it's 11 spaces to the left. And that's just that number. The question is, what's the gravity pull between Homer and his donut if they're 2 meters away? So this is 2 meters away. Well, what are we going to do here? Well, I'm going to figure out how much gravity there is between Homer and his donut. There's the formula. The force is what I want to find. The gravitational constant is that number, and I'll help you put that into your calculator in a second. One of the masses is Homer. The other is his donuts. Notice that those are both in kilograms. And the distance between them is 2 meters. And then we can just substitute in. And then this becomes a bit of a calculator exercise. Times 100 times 0.5. Remember, when I put brackets in there like that, it's meant to be times. Then divided by 2 squared. And then we'll do that on our calculator. Let me just find my calculator. All right, there's the calculator. And so I'm going to put this long expression in and help you figure out how to put that in. And I could put big brackets around the whole thing, but since I'm doing all this stuff's multiplying and dividing, there's no adding or subtracting, I'm just going to put it all into my calculator in one step and see how she looks. 6.7, and this is times 10, and then your exponent button. On the graphing calculators, it's that as the exponent button, but for a lot of people, the exponent button is that button. Some people have that button, but that's the exponent button. Negative 11, and negative 11 there, negative 11 like that, and then times 100, times 0.5, and then divided by 2 squared, or 2 to the exponent 2. You could do that as well. And the calculator will pound away at that. That's a weird number. Well, let me get that down. That says 8.37 e negative 10. That's common to see that e business. Some calculators will write it e, some will write the little minus 10 up high. But what that means, it means this is in scientific notation. 8.375 times 10 to the exponent minus 10. Okay, that's what that means. E negative 10 means 10 to the, that's scientific notation. Again, big and small numbers are always given to you in scientific notation. And again, because it's a minus, this is a very small number. So there's not much gravity between Homer and his donuts. Might be other forces at play between Homer and his donuts. Okay, let's keep going. How big would the donut have to be to have a force of 0.001? So notice that in scientific notation, this is 1, 2, 3, 4 places. So this is actually 1 times 10 to the minus 4. This is a lot bigger number than we just looked at. So this is a lot more force of gravity. Still not very much, but how big would the donut have to be? Well, let's figure it out. We know the force is that much. The gravitational constant is still the same. It's always the same. That's why it's a constant. Homer is still the same amount. And the donut is, we don't know, and we're going to say that they're 2 meters away. So how are we going to solve this? Well, one thing we could do is we could rearrange this and then substitute in. That's kind of like method 2 from yesterday. I'm going to use method 1, and I'm going to substitute in first and then solve. M is what we want to find, divided by 2 squared is r squared. And you see this part here is just a number part, right? So I'm going to pound that into a calculator. Just as it appears, blah times blah divided by 2 squared, and I should get, in scientific notation again, times 10 to the exponent minus 9m, and then on this side I still have my f value. Now how do I get m alone? I've got to divide both sides by that big number. Actually it's a tiny number, but it's a long number to write out again. And I'm going to show you how to do that on your calculator, because I'm not showing all your calculations, but I'm going to show you how to do this one. And should this be a big donut or a small donut? Well, to get a lot bigger force, this should be a lot bigger donut to have a higher force of gravity. Okay, well, let's do it. 0.0001 divided by, and I'm going to put this in brackets now, brackets 1.675 times 10 to the exponent, not 11 to the exponent, almost blew that, 10 to the exponent negative 9, bracket equals 59701. So the mass is 59701 kilograms. Now that seems like a pretty big donut, but just how big is that? How big is 60,000 kilograms? Well, have a guess. Think of something in your mind that you think is 60,000 kilograms, and we're actually going to find this out. I'm going to go to the internet in just a second to find out. Okay, so what do you think? You got a shape in mind? An object in mind? Well, the first thing I thought was maybe it's a truck-sized donut, and you Google that and you see that this is a small truck, but this truck weighs about 4,500 kilograms, and the mass of this donut is going to be 10 times that much. So this is 10 trucks sized donut. The next thing I thought is maybe it's a whale sized. And a blue whale is the hugest whale. It's the hugest mammal on Earth. And the largest of all known animals, the blue whale, was 140 metric tons. So that's 140,000 kilos, right? And we were at, this donut was about 60,000 kilos. So this is a small whale sized donut that would give that force of gravity between Homer and the donut. So that's pretty cool. That's a pretty neat number. The other thing that we could change is we could change how far apart Homer and the donut was. So on this one, we still got that a little bit higher number force of gravity. Gravitational constant still that number, 10 to the minus 11. Homer's still the same weight. And we're going to go back to our original size donut, but we want to know how close they should be. And so it's that one that I want to find. It's R that I want to find. Now I'm going to do the second way is to rearrange this first. So what steps out what I want to do? Well, I want to multiply by R squared, just so this having the thing we want to find on the bottom is no fun. So I'm going to multiply, because that's the opposite of dividing, by R squared. On this side they'll cancel. On this side I'm left with R squared F equals GMN. And then I'm going to want to divide by F on both sides. Divide by F on both sides. That's getting messy. Let me fix that up. Divide by F on both sides. On this side they cancel, and I'm left with R squared. And then finally I can get R alone. What's the operation that gets rid of squared? Well, it's square root of both sides. So square root both sides. And there's my formula. What I need to do now is I can substitute in and then use my calculator. When you hit your root button, you want to make sure you use brackets in there. So again, I got my G is 6.7 times 10 to the exponent minus 11 times Homer's mass times the donut's mass, all divided by the force, which is 0.0001. You pound that into the calculator, and you should get the same thing that, oh, not the same thing, rather. Well, if you did it the other way, and I'll mention that in a second, that's meters, right? So how many, like how big is that? Well, if that's meters, 2 decimal places would be centimeters. So about a half a centimeter, or we could say 6 millimeters away, would cause that sort of gravity. Notice these two examples on this slide show the two ways for us to rearrange these formulas and substitute and solve these problems. This one, we substituted first and then worked with the formula. In this one, we rearranged the formula, got the new formula, and then substituted into it. And again, you're building your own style. You should have, which way did you like best? Did you like doing it this way best, or did you like doing it the earlier way best? You should have an idea of which way. Okay, I'm going to pick up part 2 in just a second.